Next up, we have June Zakrajsek, who is the head of the Radioisotope Power System Office. June, I see that you're on the phone. Do you want to, do we have to unmute her, Matt, or can she unmute herself?
I think she can unmute by either hitting *6 or *9 on her phone.
*6 or *9. June, if you can hear, oh, there she is.
There we
Fantastic.
Go.
Thank you.
Okay.
Welcome, June.
Hi, and I did call in, but I also am online. I just did that in case I had an issue. So I don't know. So we'll see. I don't know if video is showing. I have that off as well, but who knows?
You are truly a member of the NASA family. Redundancy in all ways, yes?
Yes, yes. Well, with my last presentation, which kind of kept crashing with OPAG, I figured I'd better have backup. So,
fantastic.
Anyway.
All right, so welcome. So glad to have you back with us. As we've said before, you know, there are parts of this type of mission that are completely inseparable from the idea of the mission. And radioisotope power is very, very high on the list, if not at the top of the list. There's no way to do this without a couple of RTGs. And so we're really pleased that you've over the last few years had time to look at what we're doing, understand what we're doing, and then share with us where the program is. Kirby will drive your slides for you, and we'll if anything crashes along the way, don't worry, we will we'll bring you back in and keep you going. Okay.
Sounds good.
All right. Thanks. The floor is yours.
Okay. So I was asked to give an update on where we are with RPS program and our systems, and so that's kind of what I've put together for you. If you go to the next slide. Thank you. So again, I just remind everyone that the reason why we're here is because of you guys, because of missions like ISP, right? We provide the power so that we can explore and do these really cool missions and discover and understand new things. And it is a tenet throughout the program is that we're not here for us, we're here for you. Can you go to the next slide? So what's the current state? I'm going to talk to you a little bit about some personnel changes within the program, and I think it's important for you to know about these. And they're conscious changes, and really what we're trying to do is make sure that, you know, for the next 5 years, we have a very stable team. The next 10 or more, we have a very stable team. And so we've put people in place and put a structure in place that will allow that. And therefore we can support ISP missions like ISP in the future better. We're also investing in new technology. This isn't as pertinent for you guys, but just so that you're aware, we are looking at this decade and investing in new low-level TRL technology that might be able to be on-ramped into systems in the next decade, okay? But we are still in this decade working on bringing back the GPHSRTG production line, and I'll talk to you a little bit about that. I think that's where you guys will be most interested, as well as we are working some dynamic RPS work and bringing hopefully to fruition a higher efficient system. And then we constantly are in partnership with DOE and work with them on constant rate production, or CRP. We've sized that right now to meet planetary missions, and we look at it every year around the PPDE time, so spring, it's a spring event. We look at what missions are we considering supporting in the next 10 years. And we make sure, working with DOE, that we are ready to meet those missions. And we have looked, I know I had OPAG, Outer Planets, ask us to say, hey, if we had this mission set, what could you do? And so we have the ability, and I'll tell you why in a few slides, to be able to do kind of what if scenarios. We are very careful about when we do them and how we do them, but we do look at that so that we can make sure we're sized right, so that we can make sure we can support the missions. Right now, we're on a 10 to 15 fuel clad per year production rate, as well as getting to 1.5 kilograms from heat source material by 2026. The other thing is that we have capacity in the system, and I'll talk a little bit more about that in a few slides. Next slide. So I added this because I want you guys to know, please always feel free to contact me. I am definitely here and absolutely love the missions and love working with the mission community. But the person that we have in the program for this, and that's where this different color blue box is in the mission integration element of the program. And we have a new person, however, he's not, he is familiar with RPS. He's not strange to RPS. His name is J. Michael Newman. Some of you might be aware and know him. So he has a good background, either being part of studies that we had done at Glenn with Encompass, or also supporting some of the reviews that we support as part of the announcements of opportunities. And so he is quite familiar, although Michael has a new addition to his family. And so even though he's part of us, he is out for the next couple months playing with his new baby and his expanded family. So he is a good person to connect. We also added Ryan Edwards, and he is new to RPS, but is really jump-starting and coming up to speed. So you can always contact Ryan. And the person that's been doing this for us for the last year since Carl Sandifer moved on is Lucas Rich. He was actually to come over to be a deputy for the program. He is IPA from an interpersonnel exchange, right, from INL. And has worked really well because we've learned a lot more about DOE and INL and their operations, and INL in return learns a lot more about NASA and how we operate. And so that's always great for a partnership. But those three people are the folks that are on point for the missions. And feel free to contact them. We also have something called rps.nasa.gov. You could email that, and it'll end up coming to the program, and we will help support you. So if any of those kinds of things come up, I just wanted you to be aware of of some of the new names in the program. If you go to the next slide, please. So in constant rate production, what is Department of Energy done? Well, they have developed a material management model, and it's really important. It actually allows them, and they already knew, but it automates the way that they know where everything is within their system. No matter what lab, right? There's 3 labs that are utilized for CRP, LANL, Los Alamos, Oak Ridge National Lab, and Idaho National Lab. And so it allows them to look across that and helps them optimize, and also helps them and us understand pinch points and how we can support the missions. And so they have that in place. They also provide to us an integrated program plan for CRP, which allows us to understand a little bit better where those pinch points are, what kind of equipment. You might remember some of the equipment is rather old, and so we need to do maintenance on it, or modernization of it, or replacement of it. And so all of that stuff is captured for us, and we agree as to how that's going to be done. And then we also established with them a joint risk tracking system, so that we kind of know, and they kind of know what we're most concerned about and how we're buying that down. And again, that fits back into their integrated program plan. Right now, the big thing in our mind is they've shown that they can do the fuel clad pressing, right? That 10 to 15. They've actually done more than that over the last few years for us in a year. So we're not worried about that, but they are in scaling up of the heat source material. Some of the things that you see to the right are necessary for that scale up. So right now, this yellowish kind of picture here shows that Oak Ridge, this loadout cell, they're doing testing and prep for a readiness assessment so that they can bring this on as part of the line that will happen within the next few weeks to month. And this will allow us to ship, or allow them to ship, instead of shipping like 10 grams or so, or even a little less, they'll be able to ship hundreds of grams. So you can imagine when we're trying to get up to that 1.5 production rate, why things like this are important. They also have installed this automated pellet press, and they're looking at installing the second one of those that allows them to take and press the new Neptunium that we need to put into the reactors to get up to scale. So there's a lot of the scaling up of focus for us right now, as well as regular optimization of those processes and maintenance and modernization. So if you go to the next slide, please. Our current systems, you know, we have MMRTG. It's a multi-mission RPS. It allows us to go to a planetary body that has an environment. We have RUs. And so those are both available. And I'll talk a little bit more on the next slide about both of those. So if you go to the next slide, please. So both F1 and F2, which are on Mars, moving around, they are both healthy and doing quite well. If you notice, our current power is 112. Our spec power is 110. So DOE did a great job of delivering that to that mission. We also, working with them in other areas of the program, did a good job. DOE alone was able to bring that system in and deliver it to Mars during COVID, right, for like 13 million under budget. So you'll hear me talk about being very conscious about that, right, in a few more slides. So that was great. F3 is on the shelf, as well as 148 couple module flight that could be used, flight hardware that could be used in a new generator. F4 is under contract, and there has been a conscious decision that F4 will be slated for Dragonfly. There will be some small modifications on the fin length to maximize the heat for that mission. And so we will be specifying that to meet Dragonfly's needs. But we still have F3 on the shelf. And then we have the ability to build F5 and F6. That is in the contract. Whether we execute that or not is really looking ahead at that 10-year window and seeing what we need. If you go to the next slide, please. For RUs, or light rate radioisotope heater units, which I just say RUs because, as you can tell, I'm tripping on all those words. We have a number of them, about 50 so on the shelf. I don't think you guys are going to be looking at them, and even if you were, I don't think you want the ones that we have. These are Cassini air kind of RUs, so they already don't have the 1 watt thermal that RUs are designed for. They're about 0.8. And of course, they degrade every year as the heat source material decays. And so, but we have worked on reconstituting the capability, and we keep doing a little bit more every year so that we can bring back the ability to manufacture these, although we don't really have anyone clamoring for them as of yet. So it's, again, a balance. We have done this programmatic EA that allows us for a NEPA assessment. It allows us to meet the NEPA requirements in a little bit more pragmatic of a way, alignment with how the agency itself is doing it. And NEPA is a governmental function, all right, as well as we should, by the end of this calendar year, finish the system-specific documented safety analysis, which will be used as an input into the safety analysis report that the Department of Energy uses or creates for us so that we can get launch authorization. Right, next slide, please. Now, we are making technology investments, and we are working on this next gen RTG Mod 1, which I'll talk about which I think is mostly what you guys are interested, as well as dynamic. And so I'll talk about that on the next page. You would go to the next page, please. Thank you. All right, so next gen, you might have heard there's next gen mod 1, there's next gen mod 0, and mod 2. No, go back one, sorry. So what we have is we talk about next gen mod 1. And if you could go back a slide, I don't know if it's just my system that's this slow. That's perfect, thank you. I say it's approximately a GPHSRTG. Okay, it's not going to be exactly, guys. Okay, I'd love to call it a GPHSRTG, and maybe I am splitting hairs, but here I want to be upfront and make sure it's clear. So when we had the GPHSRTG, we had a slightly different heat source module, and so okay, there's another lag. Sorry, if you go forward, but anyway, we have a different heat source module. What we have to do is we have to change that heat source module in the design to use what we currently have, which is step 2 module. And I'm actually on the page that says next gen mod 1 is equal approximately to. Yes, that one.
Okay,
that
we're
one.
on next gen
Anyway,
mod 1. Sorry about, there's a long lag in the slides apparently.
Apparently, sorry. So this is the one. This is the right one. Thank you. So I'm saying approximately because we've got to make design changes to this because of that. And then the other thing that we're looking at is this will likely be a 16 GPHS module system. We're looking at, can you have it in half? I don't know. I don't know that the risk is worth it, but the contractor who has been selected, who's under letter contract, who should be under full contract within the next month, Aerojet Rocketdyne, will be evaluating that for us so we can understand the risks and the cost benefit to that. So we are establishing a production line for the for this capability for the GPHSRTG, and then let's talk about that a second. Those other changes that I'm talking about do not make a change to the heart of the generator. The heart of the generator is the thermoelectrics, the silicon germanium thermoelectrics. Those are what allows us to look back to all of these past missions that we've had. They were in the multi-100 watts, they've been in the GPHSRTGs. And so they are, shown great dependability and long life. We need to bring them back for the 3rd time, just to let you know. We created them once, or DOE did, and their contractor, they brought them back a 2nd time, and now we're bringing them back a 3rd time. One of the reasons why we have a sustainment requirement within the program, I guarantee it. And so we are very conscious about not losing the capability again, but bringing that back. Again, that's why we talk about a 90% heritage design. Now, we still are looking to increase the performance later in the life once we get back mod 1 and the GPHSRTG. So we are, and I'll talk on the next chart, and you could probably go to the next chart at this point in time, but I'll start to talk. Anyway, it will allow us to basically think of it as taking out the existing thermoelectrics and putting in a new set that would hopefully be higher efficient. This is where we originally started. We wanted to get a system that was about 290 watts electric at the end of design life. So that's still our goal to the technologists. The technologists are working. They are working towards that. Whether they are, the first thing we are starting with is making sure they understand their interface requirements correctly. So we have a very high level document that has been written and processed through the board at the program. And the actual specifics as to the details of some of the parameters will come from Aerojet Rocketdyne, because we don't want to make a change to the generator. So they need to know what the interfaces are to the current thermoelectrics so that they can develop the new thermoelectrics to meet that. And so that's the only thing that next gen project that's concentrating on Mod 1 will be doing for Mod 2. But the technologists are looking at metallization. It's a process that we need to create new thermoelectrics, or you use in thermoelectrics. They're also looking at, you start with pucks, fabricating pucks, looking at repeatability and things like that. They are trying to develop, the best scenario would be to develop this technology such that when the Mod 1 or the GPHS RTG lookalike rolls off the assembly line, that you are ready to start to try to transition this new technology in. The level of funding is lower than what we would need in order to make that happen. We will evaluate it every at the next PPDE cycle, but it is likely that the demonstration of a TRL-6 will be later than 2027. Go to the next chart. Dynamic, we've been working within NASA. We have 3 contractors that are looking at developing a more robust and reliable converter. We are just starting a flight system design through INL. We have gone out through them, competed. I would expect that within the next couple of weeks, they'll make a selection and announce that. And then to at least the people that have proposed. And then we will continue on to go through a PDR level and a brass board level. And we'd be looking at meeting the multi-mission requirements, but going to a proto-flight system that's developed mostly for a lunar demonstration. 2 of the 3 technologies that NASA has developed is developing and maturing. The Sun Power free piston Stirling and the American superconductor free piston Stirling has been shown and demonstrated to have individual converters on test for over 14 years, and they haven't required maintenance. So they do show long life and reliability in that respect. However, I'll call what we have on test the fathers or mothers of these small design changes that we have made over the last couple of years, so that we have a little bit more robustness in the system. If you go to the next slide. This is just in here for comparison. The GPHS RTG and the MMRTG are the only 2 that you can really count on the actual numbers. The other ones are predictions. And I didn't really talk about Mod 0 a little bit ago, but let me talk about Mod 0 now. Mod 0 is the ability to take a existing GPHS system and refurbish it. Our first attempt, the project's first attempt, was to use the qualification unit that they had for the GPHS RTG and refurbish it. When they opened up the system to do that, they found that there was enough damage, I'll say there, that was not going to be practical or beneficial. And so now they are doing that with another F5, which I think was one of the backup systems for New Horizons. And so they are in that process. So, again, and we work with, the program has something called the Surrogate Mission Team. It's led under Jim Kinnison. And that's, he works across JPL and Goddard and APL. And we're trying to make sure that whatever we would develop there, that missions would be comfortable in flying it. Right. So we don't want to expend a lot of money on something that people would not end up flying in the end. So we are, we've seen our concerns with using decade-old flight hardware in Artemis. right? And trying to bring it back. So we do want to be careful about that and make sure that we don't overpromise or put money into something that people aren't interested in counting their mission on. All right, next chart, please. This is a power degradation chart that the program and Ryan's been putting this together. The initial chart came from Ralph, so we appreciate that. But what we're trying to do is we're trying to underpin all of the data for this. We have some of the data. I think we have a little bit more than what we had, what we started with, but we don't have all of the data. And so it's one of the things that RPF should have for the community is to get back and get that heritage data. And so that you can, you know, understand the past and where we're going. You can see that the GPHS-RTG or the silicon germanium thermoelectric couples like which are on Voyager, you can see that they really do have a longer life than what we would say is our lifetime requirement, right? We have a lifetime requirement of 17 years, 3 years storage, 14 years mission, and combination pretty much thereof. But you can see it lasts a lot longer. Jim Kinnison, working with our lead for systems formulation, David Warner, is working on language to try to work with the community to let folks know that this does last longer. What the requirement would be, I don't know what would be a requirement, but it would be a parameter that would be allowed to, that we would be able to communicate the idea that you can last a lot longer than the verified requirement that we have for end of design life EODL. So I'm hoping to be able to share that maybe the next time, but if anyone has thoughts about that, please feel free to reach out to both Jim and or David, and we'd be interested to hear, because we do think that this might be something that we would put out there, and then the missions would more be on point to, if they had to, verify the requirement. And so I definitely think that's a conversation with the community. All right, if you go to the next chart, please. I think this is my second to the last chart. So again, we talked about focusing on the mission community. You know, I try still to make sure that we're affordable, and we try to look for ways to reduce costs to the missions, whether that is system contracts with multiple copies that allows us to reduce costs, how CRP is being operated by DOE, and where we can take opportunities for collaboration. That also happens. And we also look to all these changes in policies and how we, you know, are positioned to better get through the requirements that we have for the policies and reduce the costs and the timelines. So that would be the NEPA timeline, the launch authorization timeline. And then lastly, you know, we have these new vehicles that are on ramping, not just SLS that Rob was talking about just a little bit ago, but we are also on ramping some vehicles like the Vulcan that use what I call LOX methane, liquid nitrogen, LOX propulsion or elements. And those will have a different environment if you had a bad day. And we need to understand what those environments are. So we are starting this year working on testing that allows us to understand some of the parameters such that we can provide information to the Department of Energy so that they can create our safety analysis report, which is required and necessary for us to get launch authorization. We put priority on that kind of stuff over some of our technology development because we understand that that's something that the missions will need. And so we want to make sure that we are prepared. We also have worked really hard to work with Space Force so that we have a collaborative environment so that we can, I'll say leverage, I'll put quotes around that, but leverage work that they're doing and work that we're doing both for our own needs and share information and data. The other thing is availability, users information, models, computer models, hardware simulators. We have all of that kind of information. If you guys need it, please reach out. We'll be glad to share that with you and work with you on that. And we've even, if missions are interested in doing some concept studies, design reference missions, and they need somebody that really understands the RPS, we will help provide that to the mission. And if it's a reasonable study, a couple months study or something, at no cost, right? That's what we're here for, is to make sure that you get the best information possible on the systems that we have. The other is, we talked about the capacity in the system. You know that it's sized to Planetary's needs. And so that is something that I think ISP might be interested in and working into if it comes up on our matrix for what missions would be over the next decade. And then we do look at critical providers and what they need, looking at balancing our risks, as I've said. And we're really looking to be ready for not only this decade, but the next decade. We're not short-sighted. We're not just looking to tomorrow. We are looking for decades down the road. If you go to the next chart, please. So we are looking forward to the decadal coming out. I'm sure a number of you guys are as well. That will really help us understand a little bit better what's happening in the next, decade. And then, of course, science mission directorate and Planetary will work together to understand how that maps, right, to the needs and the funding that hopefully Congress provides us. But we're here to make sure that we provide them with all the what-if scenarios and the considerations that they would need to meet those missions and to support the missions. But if they told us that we needed to, gear up and support more missions than what we currently have planned, we can do that, and we understand the knobs and levers that we would have to turn and the approximate costs. And so we're ready. We are mission oriented in what we do and how we are focused. So that gives you an idea of where we're updated and the status of RPS. So if you guys have any questions.
Thank you very much,
I'll be
Julie.
glad to. Mm-hmm.
Thank you, fantastic. And I'm really pleased to see the direction of going back towards a GPHS RTG mode of operation down the road, because as we've talked about, that'll be very helpful to Interstellar Probe and other missions that have this kind of scope to them. So we actually don't have time for questions, June, right now. Two quick notes. Rob Stokes from SLS says that you guys were very helpful working on the RTG encapsulation question for SLS. So thank you very much. And Marshall Eubanks asks about low power wattage, 1 watt generators out of RPS units. And I know that that's an area that's been studied quite a bit in the past. So if there are more questions that you all have about RPS, I know that their website's got lots and lots of information on it. And thank you very much for joining us today, June.
Yeah, no problem. Thanks, Michael. I'll text or chat back some of those answers. Thank you.
Great, thank you. Awesome. All right.